Hello, everyone. I hope I am audible, and thank you everyone for joining in on a Friday evening. So, over the next few minutes, what we are going to do is to talk about data science, data, in fact, to begin with, right? How is data collected across different industries? Why are we calling it the new oil, right? And what are the various problems that we are solving across various industries using this data? And eventually we'll talk about why data science is both art and science, right? Before I get into the details, just a brief about myself. So my name is Vamsi. I've been working with American Express probably for the last 11 years, 10 to 11 years. Graduate from IIM Bangalore and BITS Pilani. Post that, joined American Express as my first company, post my MBA, and been with the company since then. So what do I do at American Express is typically I build MLAI models for credit and fraud purposes. I focus primarily on credit and rest of my colleagues focus on fraud. And what do I do as part of credit is essentially build features, build models with an aim to predict credit risk, right, for commercial institutions, right? What that means is if there is a company and if Amex is going to give out a product, it could be a card, it could be a loan, etc. What's the chance that the company will default on the loan or product that we have given to them, right? So that's what we do. And so that's my brief introduction. So with that, let me get directly into the agenda for today. So the first thing that we'll cover is, as I said, the data, right? How the data is collected across various industries and how is it powering various stations. And number two is what kind of decisions are being made using the data. Again, I'll touch upon a few industries and probably deep dive a little more into the banking industry because that's where I come from. And number three, I'll talk a little more on data science with respect to both how is it an art as well as how is it in a science. And then I hand it over to my colleagues to take you through the rest of the details as well post that. And at any point in time, just feel free to stop me in case I'm not being very clear, right? And or in case you need more details. So with that, let me just get into the first section. Is data the new oil, right? So why are we comparing data and oil? Right? So if you just look back to the 1800s, the industry revolution was powered by oil, right? So right from the usage of electricity across various industries, right? And electricity generation was primarily dependent on oil, right? In that sense, oil was directly or indirectly impacting every industry and in general the economy, right? And led the industry revolution. The equivalent of that is now we are in the information revolution, right? Where we have lots and lots of data, right? So oil in 1800s is equivalent of data in the 2000s. So it's a raw material. And then what happened to oil was probably the invention of, let's say, internal combustion engine, right? The engine that we have in our vehicles today. That led to the usage of oil in a much better manner, right? It led to innovations on transportation. It led to innovations on electricity or power supply, right? Various other things happened. Similarly, what data science is doing is taking the raw material, which is data, and converting it to decisions which can power various industries, right? So in my mind, the way I visualize it is oil is equivalent of data and the internal combustion engine is equivalent of data science, right? And today, if you look at how data is present, it's present across all industries. Everyone is collecting data, and we are moving towards an era where data will be the primary driver of decision making, right? Both in the public sector as well as the private sectors, right? So what kind of data gets collected across various industries? I'm going to take use case of 3 to 4 industries and talk through what kind of data gets collected, right? So I'll start with retail. So in the retail industry, if you look at what data is in general collected, one is inventory data, meaning what are the stocks that are held by the organization, which of the stocks are being held for longer periods of time, which ones are being held for very short periods of time, etc. Number two is customers purchase data, product purchase data, meaning let's say you buy something from, let's say, the More or the Big Bazaars of the country. what are you buying, right? And how frequently are you buying it? And so that's basically the product purchase data. Geographical data is, let's say, the retail industry, or let's say example of More or Big Bazaar, they might be present across various locations within the city or the country, right? So which of the locations are doing well, which locations aren't doing well, right? What's the correlation between the location and the demographics, etc.? All that is contained in the geographical information. Product information, again, is within, let's say, a category, which products are running out faster as compared to the other products, right? For example, in the detergent category, Surf Excel might be running out faster as compared to, let's say, Ariel, right? So, or the Tide, right? So there is always a product comparison that can happen within a category. So all this is kept track of to understand which products are moving faster or which aren't. Product placement is, again, let's say within a store, right? Where are the different products being placed, and right, how is it impacting the movement of products, right? So some, let's say, a brand which is placed above the eyesight, right, on a rack, probably will be moving much faster as compared to a product which is placed in the last row of the rack. Okay, so where is it placed within a store, again, gives us a lot of insights, and that is in fact stored by the retail chains or the retail corporates. Payments data, again, how are the payments coming through, right? Is it the UPI payments? Is it card payments? Is it cash, right? So that you understand the demographics, you understand the risks of various kinds of payments. So these are just examples of what kinds of data gets stored by a retail industry. Similarly, on the finance or the banking side, let's say somebody takes a credit card, right? They use a credit card for, let's say, various purposes, right? So then what information gets stored is how they are spending on the credit card, right? Are they spending at a particular shop, or are they spending at a particular time of day, right? Or are they spending more on the weekdays as compared to weekends, or the vice versa, etc. And so we get to know spend behaviors of customers using spend data. I'll touch upon this a little more in the subsequent slides. The next one is probably bureau, right? So not sure if all of you understand bureau, but generally the way bureau works is, or the way you should think of bureau is, it's a central agency that's sitting inside a market, right? It's an agency through which institutions swap information about each other. Just to give you an example, let's say you got a mortgage loan or a housing loan from ICICI, okay? Probably 6 months ago. And then let's say you're not making those payments to ICICI towards that loan. Let's say 6 months later, you apply to American Express for a credit card, right? Typically, what I should do is, given you're not paying down your loan, American Express should not give you the credit card, right? But how does Amex get to know this information, right? It does not have a direct relationship with ICICI, right? So the way it happens is through the bureau, right? So every bank contributes its data to the bureau and gets data back from the bureau. The thinking is, we need to know what the person or the consumer is doing across various banks or institutions on his or her loans, right? So that's why bureau is very, very critical. Similarly, we get payments data or demographic data. Payments as in, like, is the person paying the credit card bill on time? Is he paying the entire amount, right? Or is he making payments to auto debits, right? So different payment mechanisms mean different level of risk, right? So, and then demographics, bank account information, asset information. So all this, again, is something that banking institutions retain and use for decision making. So I'll take you through a couple of examples from this industry in the subsequent pages, because I come from this industry and I know a little more on this. So I'll take a pause here to see in case there are any questions so far from any of you.
Please drop your questions in the chat. If you're not able to have the mic, probably I think you can have the chat box. You can post your questions. Okay. Questions all clear, sir.
Okay. So let me go ahead.
Yeah.
Okay. Few more examples. I'll not go into everything here, but just a couple of points. On the healthcare, again, what we are working towards, I'm not sure whether all of you have heard of the National Healthcare Portal that the government is trying to build. So thinking is, for a particular human being or for a particular patient, we need to have the entire data about that person, right? What kind of data can a healthcare institution have is, for example, the health records, which is all the diagnostic tests that happen, right? So we can have those reports. Or personal health records are essentially your prescriptions for the last few years. What kind of medicines have you been using, right? What have been your habits, etc. Patient portal data, again, is more on demographics. What's your age? What's your genetic lineage, right? What are the diseases that your parents have, right? And patient engagement data is all the Fitbits that we are using today, right? They track your heartbeat, your pulse, right? The number of steps you take on a daily basis. So all this data is something that healthcare institutions have started storing so that they can make better decisions. Right now, it's more on the research side. It's still not being used to prescribe medicines, but eventually it'll get there post all the research. And entertainment industry is all your Netflix and Hotstars, etc. What kind of data do they collect? Is the viewing and listening records, right? So that they can recommend the right videos to you. The social media content, for example, is which content is getting critically punished on the social media as compared to which content is critically getting praised in the social media, right? So again, all various kinds of information that the OTTs and entertainment industry is putting together so that it can make decisions which are very critical for its industry, right? I'll talk about some of the problems that each of this industry is solving using the data that they're collecting. But in general, the key takeaway is every industry is collecting data and they're trying to solve problems. Some of it is in the nascent stages. Some of it is in the advanced stages. For example, banking industry is quite advanced in terms of how they use the data, but probably healthcare is still in more on the pharmaceutical research side. It might be there, but in terms of patient prescription, it's still not there, right? So different stages of analytical prowess across different industries. Okay, so now that we have spoken on what kind of data gets collected by various industries, what kind of decisions are being driven by this data, right? Again, the same for industries, right? I'll start with the banking industry on the top left, right? So what are the decisions we take on day-to-day basis? Let's say somebody applies for a credit card, right? Should we approve the credit card application or decline the credit card application? This is a question, or this is a problem that we solve using data, right? Number two is, let's say on a credit card, what should be the limit? Let's say we approve and say that, okay, we are ready to give you a credit card. What should be the limit? Should it be 1 lakh? Should it be 5 lakhs? Should it be 10 lakhs, right? Again, that is a data-driven decision that we make today. Let's say somebody's gotten the credit card. Let's say they've got a limit of 1 lakh. Now they started using the credit card. There's a very high chance that some of the transactions might be fraudulent, right? Somebody stole your card, or somebody is impersonating you using your personal ID details, and they are using your card, etc. So which transaction is fraudulent? Again, is a decision that we make on every transaction that happens in the banking industry. And then on a day-to-day basis, let's say somebody is holding the card for the last 2 years or 1 year, and we know that the person's income or the assets are going up, then should we revise the limit, right? Should we increase the limit or should we reduce the limit? Again, these decisions are taken on a very frequent basis, right? So these are some of the problems. I've just listed down 4 here, but probably there are hundreds of problems that we solve on a day-to-day basis using the data that we have. On the retail side, again, what kind of problems do we solve is how do we maintain a lean inventory, right? So the inventory is always costly because some of the inventory might be perishable, right? Some of the inventory might just add to the credit period, right? So how do we maintain a lean inventory is a problem that most of the retail chains face, right? Again, they have the geographical data. They try to understand what are the best products in this area, because the products that get consumed in a particular area are highly correlated with the demographics of that area, right? So they try to understand that, right? How should the product be placed, right? Which product should be placed on which rack? Again, a lot of analytics goes into it. And what should be the pricing of the product? If there are private labels that each of these institutions is trying to develop, let's say More has its own private label SKUs, right, or products. How should they price the product, right? Basis all the other data they have, they do that. So again, these are examples of problems that the retail chains solve on a day-to-day basis using the data. On the healthcare side, again, some of the problems are what are the top reasons for a particular disease, right? How do we prevent a particular disease? Let's say the parents have diabetes, right? And the children might most likely get it. Then there is a research that's happening which says what are the top things the child should avoid to not get diabetes, right? So there are models that are being built using the data, and probably if it works out, you'll see that those are getting incorporated into lifestyle changes in due course of time, right? And there are certain diseases which are very, very seasonal, right? And hospitals use this data to staff up and staff down accordingly, right? And on the OTT or the entertainment industry side, again, how do we increase the content consumption, right? How do we show the relevant content for the users, right? Again, they use a lot of historical data about the customer, right? Let's say I watch, let's say Game of Thrones, probably the next recommendation would be web series which is very, very correlated to Game of Thrones, right? So they need to know the customer's preferences. Again, that's one problem they solve, right? Is the login fraudulent? So on these OTTs, what happens today is people get hold of the IDs and passwords in a very illegitimate manner and they use it, right? So they try to understand which of the logins are fraudulent, right? Basis IP address, basis the geolocation codes, etc. And what content should they display on the homepage, right? So if you go to the homepage of Netflix, what you see and what I see will be very, very different because our viewing preferences have been very different historically, right? So in general, data again is powering all the stations, and I'll go in a little more detail on the banking industry as to how we solve some of these problems that I'm calling out here, right? So I'll take a pause here to see in case any questions so far.
Please post your questions in the chat.
Okay.
Proceed, Praveen. Yeah.
Okay, got it. So let me actually ask a couple of questions in terms of the banking industry, because that's where I come from, right? So let's say there are two customers, A and B, right, who are applying for a bank loan of similar size, let's say 5 lakh rupees, right? The question is, who will you approve amongst customer A and customer B, right? And what we have at our disposal is the data about these two customers. Let's say the income of customer A is 10 lakhs per annum, customer B is 12 lakhs per annum. The bureau score of customer A is 800, which is lower risk, right? So for anybody who does not understand bureau score, essentially it's a score that's developed by the central agency, which is the bureau. And it tries to assign a risk estimate for every customer basis how they are making payments, how much of debt they have with various banks, etc. Right? So customer A has been making good payments and ensuring the debt levels are manageable. So customer A has a higher score, which means lower risk. Customer B has a score which is 670, let's say, which is higher risk. Right? Assets, let's say customer A has more assets than customer B. Gender, both of them come from the same gender. And education, customer A is from a reputed college, customer B is from a normal college. Okay. So let's say this is the data that we have about customer A and customer B. Which of these two would you approve of the bank loan? Just feel free to put in your comments on the chat. Either A or B. Yeah. Okay, I see customer A as one of the answers. Any other suggestions, anyone?
So I see only one answer from Shiva. So how about others? Yeah, Naveen is also saying A. Customer A.
Okay. So probably it's right. Probably customer A, right? The reasons is one is assets are higher, right? The bureau score is lower. Obviously, the income is a little lower, right? But end of the day, you have to take that call, right? Because different factors will have different correlation to credit risk, right? So probably in this case, 10 lakhs and 12 lakhs, it's not very, very different income. So in that sense, income is not a point of differentiation, but the others are, assets are almost 2x, bureau score is significantly higher or better. Right? So I would also probably go with customer A, right? But it's not that straightforward, right? Because in general, in reality, in the real world, we'll have hundreds of data points for customer A and customer B, right? So taking a call becomes very, very tough in a manual fashion, right? That's where data science or the machine learning algorithms come in, right? Because once you have these algorithms, you have, let's say, 100 data points for customer A and customer B. Each of the data point will have a different correlation with credit risk, right? So you feed all that to the model, and the model bases the empirical evaluation will decide who is of lower risk, right? And then you go with that person. So that's where data science comes in, right? Had it been just 3 or 4 data points like this, probably a human being would have been sufficient to take the call, right? But data science enables working with many other data points, which on a human mind might be difficult, right? When you put all of them together. So before I go into a subsequent example, I had a couple of questions again. So in the above table, which of the above should not be used for credit purposes? Which of these 5 data points that you're saying, income, bureau score, assets, gender, education, which of these 5 data points in real world should not be used for credit purposes? Just feel free to type in. Okay, I see education, I see gender. Yeah, the answer is both. That's right. Right. So we cannot differentiate people basis gender, right? So we should be fair in the lending practices. So in reality, if you're using gender to give out loans, and if you're favoring one gender over the other, that's not acceptable. Okay. So in reality, gender would not be used for credit risk purposes. And even education, to an extent, that's right. So we cannot use education for credit purposes, right? So let's say you decline a card for customer B, and the customer B asks, why did you decline my application? Right? You cannot say that you are coming from college XYZ, hence I'm declining the application. It's not a communicable reason, right? It's not a fair reason as well, right? So in that sense, gender education shouldn't be used, and in most of the banks aren't used for credit risk purposes. Okay. One other question, apart from these 5 parameters, if you were to give out loans, what are the other data points that you would look at for a loan dispersal? Just feel free to just type in. What are the other parameters outside these 5 data points would you look at if you were giving out a loan? Any thoughts, anyone? Okay. I see one answer. Okay, nothing outside this list. Okay. So there are actually many hundreds of potential data points, right? Just to give an example, how is a customer paying down the other credit cards with other institutions? Or how is a customer paying down loans with other banks? Or how is the customer paying down the utility bills? Is the customer paying down the electricity bill and the water bill on time? Right? If the customer is not doing those, how will he or she pay down the bank loan, right? So in general, there are quite a few data points that you can look at. Yeah, bureau score does cover everything, but bureau score has its own limitations, right? Especially when we don't have a lot of information on the bureau, right? For example, let's say somebody just graduated from college. The person might not have taken a lot of loans, right? So the bureau of such a person tends to be very, very weak, right? So then you'll have to depend on a lot more data items. For example, as I said, utility payments or other such payments, right? So that's where bureau becomes a little weak, but that's a fair point. In general, I think bureau covers for a lot of this. Okay, so let me go to the next page.
So in fact, Praveen, I also heard some articles that sometimes even the Netflix subscription also, they look at whether they have subscription for Netflix or these kind of data points also they look at when they are issuing these loans. Is it true to some extent?
So Mallikarjun, typically I think the reason should be communicable, right? Let's say somebody is not using Netflix and we decline it, saying that you're not using Netflix. It's not a valid reason, right? So we use only those attributes which can be communicated. If the customer comes back and say, why did you decline my application, right? So communicability plays a huge role in deciding which factors, right? Netflix subscription might have a correlation with credit risk. We are not denying that, because those who have Netflix subscription might be premium customers, and premium customers will have low risk. But still, Netflix subscription might not be communicable, right? So in that sense, it might not be used.
Thank you. Yeah.
Okay. So let me go to a second example. Let's say customers A and B. Let's say we gave them both of them loans, right, in the previous page. And one fine day they stopped paying their EMIs, right, which is the monthly installments. Now the question is, you have to decide who is more collectible, meaning who is likely to pay back, right, the money that they owe you. Okay. Again, we have got a few data points. the data points are different from the previous page, right? For example, again, income and bureau score, same as the previous page. Assets, again, same as the previous page. Let's say now we have phone numbers as well, right? Customer A is not reachable, but customer B is reachable on the phone number that we have for that customer. Customer A, if you look at her, she has paid 5,000 rupees in the last 30 days to other banks, right? But customer B has made 50,000 rupees to other banks, right? So if you have these data points, and if you had to decide who is more likelier to pay back the loan at this point in time, who would you choose?
Post your answers in the chat. Naveen, Shiva, Nagajyoti.
Yeah, I see B. Yeah. I mean, this is a tough one actually, right? Because assets of customer A are higher, right? But the phone is not reachable. The payments, if you look at the payments, recent payments, customer B has made more payments, right? So again, mixed signals, and that's where human intuition might not be very, very optimal, right? Because you'll have to go into correlations of each of these features or data points with credit risk or collectability, right? In this case, it's collectability. Right? So in reality, probably the fifth one has the highest correlation, right? Somebody who has made more payments in the recent time frame probably have cash with them, which they can pay back, right? So in reality, probably I'll go with customer B as well. But this is not an easy decision, right? As I said, this is just based on 5 points. And within these 5 points, we are seeing that there are some contradictory signals between A and B, and it's difficult to take a call. And so if there are hundreds of data points like this, a human mind probably cannot do it manually, right? And that's where data science and machine learning comes into place, so that you can take a more informed decision, right? Okay. But again, a similar question that I had on the previous page. If you were to choose any other parameter outside these 5 data points, what would you seek, right, in order to measure collectability? Any thoughts, anyone? Just feel free to type in. If you have to measure collectability, meaning they have stopped paying EMIs, right? Now you have to reach out to them and ask them, can you make a payment, right? And the question is, basis all that information, who do you think, if you had to make the choice, what kind of information would you need? The reason we have to make this choice is, in reality, let's say for a huge bank, right? There are thousands of customers who don't make payments, and it's not possible to reach out to everyone and ask for payments, right? So we'll have to pick and choose the relevant customers who can pay back the money, right? So that's why this decision becomes very, very crucial. Okay, paying bills for utilities and other payments, yeah, which is probably kind of the last point here. Yeah, but that's true. Criminal records, okay. Yeah, I mean, both are correct. Both have a correlation, but from the regulation standpoint, probably we cannot use criminal records, right? We can use only financial criminal activity against a customer. Let's say you do a theft in the neighboring house, that's also a criminal record, but we cannot use the theft against you for making a decision on a financial institution, right? We cannot make a financial decision basis non-financial criminal records. Okay. But that said, it generally has a correlation. Yeah. Okay. But I think, yeah, these are good ideas. But in general, if I were to do it, probably I'll look at email-based collectivity. Do I have the right email of the person, right? Do I know other ways of contacting the person, right? Probably I'll spend a lot more time there so that I can reach out to the person. Okay, with that, let me go on to the next section, right? So what we have covered so far is what kind of data is collected by various industries. Number two, what kind of decisions get powered by this data, and a couple of examples on how data is used to make decisions in the banking industry, right? So, and what we have seen is making decisions, credit decisions or decisions is not that straightforward because we have hundreds and in fact thousands of data points that come in for every decision that we make, right? So that's where data science plays a huge role. And what I'm going to cover next is, in general, like, what does data science mean, right? Why is it both art and science? And what are the various aspects of data science that can be learned with enough effort put in? Okay, so this is just a summary page of data science. So at a very high level, data science is a science which you apply on data so that you can gain insights from it and eventually make decisions, right? That's what data science means. It has various aspects to it. One is exploratory data analysis, which is primarily like if you have given a raw data, understanding that data a little more, right? For example, what you do there is look at the distributions and statistics, right? To give an example, let's say if you have got income data for the entire country, statistics are basically what's the average income, right? Or what's the average income per state, right? What's the distribution, meaning what's the P90 or the 90th percentile or the 5th percentile, etc. That's what statistics and distributions mean. Sample size and class details. Let's say you're trying to build a model, you're trying to predict who will default, right? So when you have the data, you will have both defaulters and non-defaulters, right? So do you have enough data points to build a model, right? Do you have enough defaulters to train your model, right? All that is part of exploratory data analysis. And eventually you need the tools and languages to play around and manipulate the data, right? So that's your science piece of it. Art, essentially the way I look at art piece of exploratory data analysis is, do you have the right gut feel, or are you asking the right questions with regards to exploratory data analysis, right? For example, are the classes well represented? Meaning, let's say you're trying to build a model. If there's a defaulter and a non-defaulter in the data, are both the classes well represented, right? Let's say the defaulters are too little, then getting insights from the data becomes very, very difficult. So are you asking the right questions when you look at the data, right? Let's say in the recent time frames, right? Let's say in the COVID period, 2020, 2021, what happened was the spend trends changed in the country, right? Let's say a lot of offline spending went away and most of the spending went online because people did not want to go out, right? So let's say you're doing an analysis for a non-pandemic period, probably choosing a data from 2020 or 2021 will be incorrect, right? So the question that you have to ask here is, am I choosing the right periods for doing the analysis, right? So that's your gut feel, right? So that's the art part of exploratory data analysis, right? In case you're not asking the right questions, your entire analysis can go haywire. Right? So just look at science and art as science is essentially the tools and the mechanisms and the numbers that you need to see. Art is about asking the right questions about each of the phases in data science. Right. The second thing, the second important pillar within data science, the way I see it, is feature engineering and feature selection. Right. Again, you can probably do univariate analysis. I know that I'm not going to depth of each of this here, but feel free to stop me in case you're not very clear as to what I'm saying. Right. Univariate analysis, correlation metrics, right, where you're looking at various features and trying to say, okay, these two features are extremely correlated, etc. So this is just the science part of it. But if you look at the equivalent art part of it, what you can ask is any trend that you're seeing for a variable. Let's say you're trying to predict credit risk, right? And income is your attribute. Let's say a higher value of income should mean lower risk. But let's say the trend of income is reverse, right? Can you explain it, right? Is the trend making sense to you, right? You cannot use features blindly. Every feature that you use, there should be an intuition behind it, right? Are the features compliant, right? We saw a couple of examples. So we cannot use gender, we cannot use education for predicting credit risk, right? So you should have that gut feel that probably we are using the wrong attributes, even though they might have a correlation. You should have this. So again, this is the art aspect of it, where you're asking the right questions while doing feature selection or feature engineering. And the last one is, again, the biggest pillar is forecasting or modeling. Right, the science part of it is knowing the algorithms, right? It could be the classification algorithms or the time series algorithms like RNN, or the natural language processing algorithms, which are like your BERT and ROBERTA, etc. So knowing the algorithms is the science part of it, but art is essentially, are we using these algorithms for the right objective function, right? If you're not creating the right objective function, which is if you're not predicting the right thing, then even if you use the best algorithm, probably you'll not get the right results, right? or once the algorithm throws out an output, you should be able to interpret the results, right? So again, this is where the art part of data science comes in the modeling pillar, right? So where I'm getting to is the science part is easy, meaning it's more theoretical. You can go through courses, you can understand it. And the art part is something that you'll have to develop a gut feel for as you start applying the science on various decisions that you're making. And in due course of time, if you're paying enough attention, both of it can be learned. Obviously, you start with the science part of it, and art is something that you develop on the job. And probably it's easy to learn as well if you pay enough attention, right? So I'll take a pause here to see in case there are any questions or I need to elaborate a little more on any of this. Okay. So just to summarize, what we have discussed so far is, one, we are probably in the first decade of systematic data-driven decision making, meaning the companies have started collecting data. I mean, probably they have been collecting data for many years now, just beyond the recent decade, but they have started putting this data to right use over the last few years, right? And this has been happening across the industries. Various problems are getting solved, right? Probably we might get into a place where another 5 years or 10 years, even the board meetings will have an AI assist, right? So the board member might be sitting there and he is asking all the board members as to what their view is on a particular problem. And eventually he'll also ask the AI assist, right, as to what the AI system thinks of that particular problem, right? We might get there, right? But the key takeaway is data has been put to good use over the last few years across industries, and data science is the way you put data to good use. It's a mix of both art and science. Both of it can be learned. You start with the science piece of it, and as you start applying science, you understand the art piece of it, and in matter of time, we'll master both, right? And it's reasonably straightforward. And that's where I stop, and I hand it over to Mallikarjun and Afia for the subsequent steps.
Yeah, thank you very much, Praveen. Yeah, so Nagarjuna is having a question on the univariate analysis. So if you want to understand more on the univariate analysis, which is more of like a science, which Praveen was clearly taken through some examples in the banking sector, how data is doing greater job. I mean, why data is new oil, and how the certain decisions have been taken using data and all that. So thank you very much, Praveen. Praveen, can you stop sharing the screen? I'll share my screen. So I'll come back to Nagarjuna, your question on what is univariate analysis. Univariate analysis is more of uni means what, single variable. So when you collected the data, you need to look at their distribution, how each data. Let's say if you see the income distribution of all the customers which you have been collected, is how it is there. The distribution is okay. Or if you're collecting something like on other categorical data, how those categories are split. So which category is more in terms of frequency, and those we call as univariate analysis. So that's actually, so which is a part of EDA, expert data analysis or feature engineering, which Praveen talked about. So to which Praveen clearly. Just a second, I'll just share my screen. Ravi, could you please give me the okay? It's there. Just a second. So to yeah. Is the screen visible? Hello?
Yes, Mallikarjun, you can see it, yeah.
Yeah, okay. Thank you. So to answer what Praveen was saying, how you mix the science and art, that's where actually we come out with a product on data science and machine learning from MIT, Manipal Institute of Technology, where we give proper training both on the science part and as well as art part, which is a mix of where we train you on the concepts, so through techniques and tools using the science part, and with the assignments and the micro projects and the capstone projects and the integrated capstone projects completely on hands-on based, which talks about the art part, which is very important once you start your career in data science. So that is being taken care of in this PG certification program by MIT. So What is this all about this program is that the course is the duration is for the 9 months completely online, which happens on the weekends on Sunday, without disturbing your work, which 8 hours you will be dedicating to on Sunday 4 hours and Sunday 4 hours. This captures both the concepts explanation as well as hands-on. Along with that, projects which will be taken, some case studies and all. And this course is divided into mainly on the basics or the fundamental concepts, which talks about like which Praveen is mentioning, more on the tools and techniques. Let's say you need a language to understand or to analyze this data, which we talk about more on the Python programming. We start with the Python programming, which is very much required for analyzing huge amount of data. So Python programming, we'll start with the Python programming, and we also talks about how data being stored in the database management like SQL, which is very important to extract the data where it is stored in various formats. It could be in the servers, or it could be in different formats. So that's where we train you on the SQL with hands-on, maybe in the MySQL or in the Oracle platform. So that's where the second course will come in picture. And for each course, we have some assessments. At the same time, we have hands-on on case studies, micro projects, which you call as a micro project, and the course specific micro projects will be there to covering all the topics that we train you. And after that, we have statistical concepts where we teach you statistical techniques for data science, and explore data analysis, which is feature engineering and all. And then also we also train you on data visualizations, which is very important at the present situations in the business scenario, where we train you majorly, of course, on the Tableau part. At the same time, we also conduct some industry session as the market demands on the Power BI part as well. So how do you use these tools, Power BI and Tableau, to visualize the huge amount of data? What are the various visualization techniques that you apply and on this data, like creating a dashboard, and how you have to create a storytelling. So those skills will be taught in this course, which is data visualizations using Power BI and Tableau. And after that, we will enter into the main part of the ML, the model building, like machine learning, which covers both on the regression part and the classification, clustering, and time series. So these are the main areas which we cover in the machine learning part, starting from the simple linear regression to till advanced time series analytics, time series algorithms. And then we ask the participants, or we give the chance or the preference to the participants to choose which side you want to make your career in. So in the area of data engineering, or in the area of advanced machine learning techniques, like say where it is in the deep learning and NLP. So that's why we have brought two specializations, two electives. So those are interested to move their career, or pursue their career in the data engineering side, they can take up the data engineering, where we train you on data engineering concepts, starting from the big data technologies to PySpark and cloud-based. How do you deploy some ML algorithms in the cloud, and ML ops also being taught in the data engineering. And similarly, those who are interested to move into the data science field only, where they have to pursue more advanced ML algorithms, they can be trained on the deep learning techniques and NLP. And of course, we also teach you the ML ops for them as well. So, and of course, at the end, we will be giving integrated capstone projects, where you have to completely use the learnings on all these courses, and build a complete integrated capstone project, combining from the data cleaning to data preparation and model building and model evaluation, which you'll be doing in the integrated capstone project as well. So this is how the course has been designed and trained by well experienced by the data science faculties. Uh, that's where we try to take care of the assessments, and we also planning in the week what is actually happening, that which we observed that in the weekend, when you're taking that they're coming. I mean, once the weekend they attended, the next weekend they not even go through that. So I am also planning to conduct some 1 hour doubt clarification session in the mid of the week, maybe on a Wednesday or Thursday, based on the learners' preference, we are also planning in that session as well to connect between the 2 weekends so that they'll be engaged or we'll be giving some lot of practice assessments or practice exercises or practice case studies, which will be working on that. So this is how actually, and the certification from the MIT, Manipal Institute of Technology, which is one of the premier technical institutes across the world, in fact, not just India. So that's a branding you'll be having from the Manipal Institute of Technology certification is. And we also have 2 types of placements as a placement guarantee and placement assistance. So based on your profile and your attendance and all that. So there are certain things for that, so which you can reach out to the academic counselors who are eligible for the placement guarantee and who are eligible for the placement assistance. But both are there, placement guarantee and placement assistance. But placement guarantee is only applicable to certain people, so which they meet the criteria. We have certain criteria to give a placement guarantee option, so that you can see that whether you're eligible for that. And then we have also, of course, we will give that those are not eligible for the placement guarantee, we'll definitely assist them to be placed. And we have well record of achieving the placement. Placements, which is more like almost like 90-95% of people are placed in earlier in the face-to-face session, which we delivered through Mahe, and we also have some certification programs through UNext. Also, we have very good record of placement assistance and placement thing. So this is about the program. So if you have any questions, I'll be taking up that. Of course, along with that, we also have a dedicated placement team, which they train you on certain non-technical skills, like it could be of soft skills or communication skills or aptitude skills, where we'll be taking care of that as well, where we conduct aptitude test, and also we train you on the aptitude part by expertise in the aptitude. So, and also mock interviews, technical mock interviews and non-technical mock interviews, so been taken care of in that program. So any questions, you're free to ask in the chat. Yes, Shiva. Praveen, you want to take this question? The job opportunities they were talking about. I mean, in a general, you're asking, Shiva. So I think Praveen will take care of that question.
Yeah, no, in general, I think, Shiva, what I would say is job opportunities, as I said, is on the rise, right? As I said, on the banking and finance side, it's been there probably for the last 7-8 years. Now the other companies or other industries are getting into the groove, right? So probably the way I see it is just the initial phases of data science, and probably a good 30 or 40-year career can be made in this field at this point in time. And various industries are moving into usage of data, right? So theoretically speaking, the number of opportunities, especially in India, will go up over the next few years, right? And yeah, it's increasing by the day. Yeah.
So to add on what Praveen said, as the statistics also says that there's a 1.4 million jobs are there in the next 2 years in the data science field, and also if you observe that what is because of the recession, the layoffs is happening, which you can see that, but you couldn't find any layoffs in the data science and the data analytics department of the division, because they are very important to any businesses right now. So that's also another thing that you can observe that which has been laid out by so many companies and all that. Yeah. The entry level packages. Praveen, you want to answer this entry level packages?
Yeah, it depends on experience, and it also depends on your qualifications, right? So I don't know. So I would say probably it can start all the way from 7, 8 or 9 LPA to about 25, 30. I've seen the entire range, right? But that's what I would say, right? It depends on the organization. It depends on the qualifications and skill set that you come in with, right? So yeah.
Yes. So the integral, which Praveen rightly said, I mean, the range is starting from, let's say, 5 lakhs to even it can go to 15 lakhs. There are cases where in the entry level, I mean, she's a very fresher. who got a 12 lakhs package from Amit Chan. So I'm just sharing our own experience. So she's a completely fresher and very good in the tools and techniques and language and the communication skill. If you're able to prove that and you are expertise in that, so then they're ready to pay with a good amount of package. So it can range from 5 to 12 or 5 to 15 lakhs of packages in the entry level. Yeah. Okay. Any other questions? Great. So thank you very much. Then, so you can Richard, Afia, do you have the link of the website? We can share this with people to go to the program, Afia, or we can put it in the chat itself.
We will share it on email, sir.
Okay. Okay.
Along with the recording of the session.
Along the recordings. That's great. That's great. Thank you, Avya. So thank you very much, Praveen. With his busy schedule, he has taken his time and very simple and in a layman language, he nicely explained about the data and taking very simple language where, I mean, even people not having any knowledge in the data can easily understand. So thanks a lot with nice explanation of, especially the BFSI side, where he brought in his expertise and explained that how they're playing the role, the data science is playing the role in decision making. Thanks a lot, Praveen. Once again, from our MIT, from the UNext side. Yeah.
Okay. Thank you, everyone. Thanks for the time and thanks for the opportunity.
Yeah. So thank you, Afia, and thank you, Ravi.
Thank you, all of you.
Thank you so much, Malka sir, to come and take the session today. Thank you, everyone, for attending.
Sorry, Afia, I didn't hear you.
Saying thank you, everyone.
Okay. Yes. Okay. Thank you. Thank you
for the session and making it worthwhile. And have a good weekend, everyone.
Okay.
We'll wrap it up now. Thank you so much once again. Good night.
Thank you. Good night. Good night, all of you. Thank you, Praveen. Once again.